In this video, we're going to learn about trigonometric ratios. You might be wondering what that means. Well, it has to do with triangles. That's what the tri part of trigonometric ratios stands for. And what we know about triangles, specifically right angle triangles, we're going to be working almost exclusively with right angle triangles here. Say we knew two sides of a right angle triangle, 10 and 12. We know we could find that missing side, right? We would use the Pythagorean theorem, right? But what if we were given, in a right angle triangle, what if we were given an angle of, say, 20 degrees and a side length of 10? Would we be able to find that missing side? The answer is, up until now, no. But we are going to be able to do that after the lesson today. And it's going to be called using trigonometric ratios. You might be able to see how this is useful because we're not always given all the sides or two of the sides on a right angle triangle. Sometimes we're given the angle instead. Sometimes in real life, it's much easier to measure angles. So for example, just a quick example here, say you had a building that was very tall and you wanted to find the height of that building. Well, if you're standing down here on the ground, you can look up at the top of the building and you can actually measure the angle that your eye is looking up. We'll call that angle A. Fairly easily. There's apps on your phone that can do it. You can use a protractor to do it, but you can measure that angle to the top of the building. If you know how far away from the building you're standing, X, you can actually calculate using this same thing, the height of the building. So this is very useful because it would be very difficult to measure the height of a building if you don't have the means to do that. But all you need is a protractor or an iPhone app and distance to the wall. So in order to do this, we first need to be able to label some things. We know right angle triangles have three sides, and there are names to each one of those sides. The first one you might recognize, called the hypotenuse. The hypotenuse is always just the side that's directly across from the right angle, if you're having trouble figuring out which one's the longest side. So we know that one already. We should be able to label a hypotenuse on any right angle triangle. But the other ones are called the opposite and the adjacent sides. And in order to label these, we need to know the given angle. So in this case, the angle that we are given is angle A, right? That's the one that we're given. That's the labeled angle. So when we look at the opposite and adjacent, we think about that given angle, and we think about which side is beside that given angle. We call that side, the side beside the given angle, we call that adjacent. Another word for adjacent is beside, right? And then the other side is the opposite side. And we know something is the opposite side when it's across the triangle from our angle. See how it's across? Just like the hypotenuse is across from the right angle, the opposite side is across from the given angle. It's opposite to the given angle. So we always can label right angle triangles with these three terms: hypotenuse, adjacent, and opposite. And we need to know how to do this before moving on. So, example. In this triangle here, the first example one, label the adjacent, the hypotenuse, and the opposite. So looking at this triangle, I should be able to identify the hypotenuse pretty easily. It's the one across from the right angle. It's the longest side. So this is the hypotenuse. A little bit difficult to write sideways. There you go. So that's the hypotenuse. So we can say, and we sometimes shorten it. I'm going to put it down here. I'm going to put HYP, standing for hypotenuse, is equal to 10 centimeters. The next sides we can find are the opposite and the adjacent. And remember, we're doing these with respect to the angle that's given. The angle that's given here, A, is this one here. So remember, adjacent just means beside. So the angle beside A, or the side beside A, is this one, this 6 centimeter one, right? So I'm going to label that, just take out the pen, adjacent. So the short form for adjacent is just ADJ, and that's 6 centimeters. And then lastly, the opposite. So the side that is opposite that given angle is our 8 centimeters here. So we would call that the opposite side. And again, down here, the short form you can probably guess for opposite is OPP. So that equals 8 centimeters. So what I want you to try now is I want you to try labeling the same thing for this triangle here. Pause the video here, label everything as I did here. Even underneath, you should list them as well, and then unpause the video to check your answer. So there we go, there's my answer. So first of all, the hypotenuse, hopefully you're able to identify the longest side, was this one, 11.7. The adjacent side, remember this is the angle now that we're given A, so adjacent means beside. So what is the side that's beside this angle? The 10 centimeter one, right? So that should be your adjacent. And then lastly, the opposite side is the one that's across from it, so 6 centimeters. So what I want you to try now, on the next page, is just a bunch more questions that are the same thing. It might look like a lot, but if you get really good at this, the next part's going to be very easy. Okay? So pause the video here. Try these 4 questions, labeling the opposite, the adjacent, the hypotenuse for each one. Unpause it when you're done to check your answers. So here we go. Here are the answers to the first 2. Remember the first question, the angle that we're considering is this one, right? Let me do that in yellow. This one right here. So the opposite side is the 5 centimeters there. For the second one, the angle we're considering, the labeled angle, we called it X in this case instead of A, but that's fine. It's the same thing. So adjacent will be the 100, the opposite will be 490. Moving on, the angle down here. This time I give you an angle, but it's the same thing. So this angle is 70 degrees here. Opposite of that 70 degrees is the 4.2, and adjacent is the 1.5. And here, the 60 is the given angle, so the opposite is the 43, and the adjacent is the 25. Okay? Hopefully that makes sense. So, once we have everything labeled, we can move on to what are called the trigonometric ratios. And the trigonometric ratio is just a fancy name for saying the ratios of 2 sides. So, for example, we have what's called the sine ratio, which is just if you take the opposite side and you divide it by the hypotenuse, that gives you the sine ratio. So, for example, if I go down here to this triangle here, let's do the example together here. So this triangle has 3 sides. The given angle that we're given is A here. So let's label the sides first. The hypotenuse we know is here. Hypotenuse. The adjacent side is the one beside that angle, right? So this would be the adjacent. And then the opposite side is opposite, the third side. Opposite is opposite that angle, right? So when I'm looking for the sine ratio, what's called the sine ratio, all I'm looking for is the opposite divided by the hypotenuse. So that's not so hard to do because I know the hypotenuse. So if I'm going to do sine, let's use a different color. Let's use blue. The sine of angle A is equal to the opposite over the hypotenuse. Well, the opposite we know is just 8 centimeters. And the hypotenuse, let me zoom in here, the hypotenuse is 10 centimeters. So sine, the sine ratio is just 8 divided by 10. If you do that on your calculator, that should give you 0.8. That's it. So we call that the sine ratio. Just the sine ratio of that triangle is 0.8. We can do the same thing for the cosine ratio or the tangent ratio. So the cosine ratio is just if we do the adjacent divided by the hypotenuse. So down here, adjacent over hypotenuse, so the cosine of A is equal to the adjacent. I'm just going to put ADJ over HYP, adjacent over hypotenuse. And the adjacent clearly is 6 centimeters. And the hypotenuse is 10 centimeters. If we do this on a calculator, 6 divided by 10, you get 0.6. So the cos ratio of this triangle is 0.6. And lastly, if we look at the tan ratio just means opposite over adjacent. So going down here, I'm going to do the tan ratio. So tan of A is equal to the opposite over the adjacent. And if we look back at our triangle, the opposite is 8, the adjacent is 6, so it's just 8 divided by 6, which is 1.333 repeating. We usually like to round it to 3 or 4 decimal places depending on the question, but that is the ratio. Now you might be thinking, why do we need to find these 3 ratios? The sine ratio, the cos ratio, and the tan ratio. That'll come clear in the next part. For now, you just need to know how to find them. Basically, they're going to help us find missing sides on triangles if we don't know the side. So what I want you to try right now is I want you to try the your turn question. And I'm just going to start you off. I'm just going to write this. What is sine A? What is cosine A or cos A? And what is tan A? See if you can find those 3 values based on that. And remember, these are always true. That's what these ratios are. They're always set up like that. So sine is just going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tan is going to be opposite over adjacent. So try those 3 questions yourself. Pause the video here. Try it. Unpause when you're done. So here we go. Here are the answers. So I started off by labeling the sides in the triangle. Hopefully you did the same. If not, that's always a good place to start. But I found sine of angle A, which is just the opposite over hypotenuse, which is 6 over 11.7, to give me, I ran it to 4 decimal places, 0.5128. I know it's a little bit hard to see that 8. Cosine of angle A was 10 over 11.7, which is 0.8547. And tan, the tangent of angle A, was just the opposite over adjacent, 6 over 10, which is 0.6. So hopefully you understand how to find these ratios for any right angle triangle. What I want you to try now is to try to do the same thing for these 4 questions here. So in this question, I'm just going to help you get set up. You're going to start by labeling, right? So number 1, label the 3 sides. That means opposite, adjacent, hypotenuse to whatever angle that you're given. Number 2, you're going to find sine, cos, and tan. So it's a little bit tricky. How do you remember which one is like opposite over hypotenuse, adjacent over hypotenuse, whatever? And there's actually a little trick. And the trick goes like this. Sohcahtoa. It's called Sohcahtoa. And Sohcahtoa is just a way of remembering what the trig ratios are, the trigonometric ratios are. So what this means is that S stands for sine, C stands for cosine, T stands for tan, O stands for opposite, H stands for hypotenuse, A stands for adjacent. So for example, for the sine ratio, this is the one that goes with sine, this is telling us that sine is equal to O over H, opposite over hypotenuse. So I can write that out. Sine of A is equal to opposite over hypotenuse. We can actually shorten it just to O and H as well. Instead of op and HYP, you can just shorten it to O and H as well. Cosine of the angle. So in this case, cosine is ka, this ka part here. That's going to tell us that it's adjacent over hypotenuse. So all you got to do is A over H, adjacent over hypotenuse. And then lastly, we have this toa part, which tells us tan is opposite over adjacent. So tan of the angle is opposite over adjacent. So once you've labeled, you write these things out, and then you can plug in the opposite, the adjacent, the hypotenuse in order to find your 3 trig ratios. So I want you to try that now. But before you do that, I actually want to point out one thing. The angle is not always going to be called A. Sometimes it's called X, sometimes it's actually a number. So in this question here, the second one, you're going to have, instead of sine A, the angle is labeled X. So we're going to call it X, sine X. And that's still going to be equal to opposite over hypotenuse always. If you go down to the ones below, you'll notice they have actual angles. You can put in the angle where that x was or where that a was. So with this one, you're going to put sine of 70 degrees is equal to, well, again, it's going to be opposite over hypotenuse. And you can do the same thing for cosine and tangent. And it's going to be the same thing for this last one. You're going to put sine of 60 degrees, because 60 degrees is the angle that you're given, and that's going to be opposite over hypotenuse. And you can do the similar thing for the cosine and the tangent. So I want you to try right now, I want you to try to come up with the 3 trig ratios for each of these 4 triangles, okay? Pause the video now and try it yourself. Okay, so here are the answers. Notice how I just labeled the 3 sides with O, H, and A for opposite, hypotenuse, and adjacent? You're welcome to do that as well, just to make it a little bit quicker. So you should check your answers to make sure that these 3 line up with sine, cos, and tan for each of these, for X and A. And then for the third and fourth question, check to see that your answers line up with these, for sine, cos, and tan, for the 70 degrees and for the 60 degrees. You also might notice your calculator, if you have a scientific calculator, it has those buttons on it. It has SIN, COS, and TAN, standing for sine, cos, and tan. If you're curious about what those buttons actually do, you can try it. Plug in sine of 60 by plugging in sine 60 or cos 60 or tan 60. You should realize something about those numbers. They should come out very close to these numbers that you're given here if you just type this part into your calculator. That's where we're going next. We're going to use that fact to help us solve for missing sides on right angle triangles.